my Data Science and Decision Science Advanced Certificate program from IIT Delhi. I am sharing here my Capstone project, which is for the data science module. This has been done by my team member Manish and by myself. So I will quickly talk about the disease. So this is a data which is related to student depression. So as you know, depression is a common mental disorder, and it involves a depressed mood or a loss of pleasure or interest in activities for a long period of time. Some of the other symptoms include poor concentration, feeling of excessive guilt or low self-worth, hopelessness about the future, thoughts about dying or suicide, disrupted sleep, changes in appetite or weight, feeling very tired or low energy, overall energy. So depression is slightly different from your regular mood changes and feeling about everyday life, and it can affect all aspects of life, including your relationship with family, friends, and community. The disease affects an estimated nearly 300 million people worldwide, and as per NMHS, in India, nearly 50% adults are having mental health issues, with about 2.7% suffering from depression, whereas as per World Health Organization, about 4.5% of Indians are suffering from it. In terms of age, if you look at, depression can affect people of any age group, but it first appears during the late teens to mid 20s. Women are said to be 50% more likely to experience depression than men. Risk factors includes like poverty, unemployment, life events like bereavement, divorce, physical illness, and substance abuse, which increases an individual's risk of depression. In terms of treatment, uh, there are known effective treatments for mental disorders. More than 75 people in low and middle income countries, however, do not receive any treatment. Barriers to effective care includes a lack of investment in mental health care, lack of trained health care providers, and social stigma associated with mental disorders. And now I am talking about the data set which we have. The data set has a total of 27,900 records uh, with 18 variables or features, and there are no null records. The data can be broadly classified into demographic data, lifestyle habits, academic and work-related pressure, specific mental health indicators. This data is spread across both the genders. There are 50%, 6% cases of males and 44% cases of females. The age group is largely between 24 to 30 years, with more than 99% of the data is of 24 to 30% individuals. There are 59% depression cases, which is our target variable, and 41% not having depression. So the target variable which we have is depression, and that is something which we have to understand and define. Now looking at the original data which we have, so this data, if we look at of all the features which we have got, these are given in numeric values or a string or text values. There are certain variables like sleep duration, which are also in numbers plus text. So first of all, we have to also prepare this data and make it usable. We have to convert these variables into numerical values. Before doing that, let's quickly talk about the data which we have got. So if we look at I will quickly talk about the various variables or features which we have. One is ID, which is a unique identifier assigned to each student record. Next is gender, which is nothing but male, female, or other gender for each student. Age of the student. City is place from which the student is. Sleep duration, the number of hours of sleep, average number of hours of sleep the student sleeps in a day. Dietary habits, work study hours. So dietary habits is an assessment of students' eating patterns. Work study hours is the average number of hours per day the student dedicates to work or study. Profession, degree. CGPA is the cumulative grade point average of the student. Study satisfaction is an indicator of how satisfied the student is with their studies. Job satisfaction, academic pressure, work pressure, financial stress, family history of mental illness, and this indicates whether there is a family history of mental illness, then any history of suicidal thoughts, which is a binary indicator that reflects whether the student has ever experienced suicidal thoughts. Depression is the target variable, which is again a binary variable where no represents not having depression and yes represents having depression. These are few variables like academic pressure, work pressure, financial stress, and job satisfaction. These variables are on a scale of 1 to 5 or 0 to 4, where lower value indicates low and a higher value indicates very high or high. We started with preparing the data, as I mentioned earlier. So we converted quite a few variables which are in text format into integers or into say numeric values. So values like sleep duration, which basically we converted that into categorical. Similarly, which is sleep duration is number plus text. We convert that into numerical value. Similarly, variables like gender, city, profession, dietary habits. Have you ever had suicidal thoughts, family history, or mental illness? They were in text format. We converted them into numbers or categorical values. There are no missing values in these, and there are few records of sleep duration which are classified as others. We imputed these with model value. So this is how the usable data or the data will look like after it has been transformed from its original form to numerical values. We started with understanding data more in detail. So we did data exploration. So if we look at some of these variables are on a scale like academic pressure, work pressure, study satisfaction, job satisfaction, which are on a scale of 1 to 5 or 0 to 4. Not much information can be obtained from that. But however, there are variables like age, CGPA, and for that matter, sleep duration as well. And if we look at these values, these variables are having a mean value and a 50% or a model value which is quite similar, indicating that there is not any skewness in the data and the data is balanced. If we look at the incidence of depression, so there are say 59% of depression cases which are classified as yes, and if we look at the split by gender, the percentage of depression cases is very similar. In male it is 59%, in female it is 58%. With respect to age distribution, the box plot clearly shows that largely the age group is between 24 to say 30 years, which we have earlier as well seen that. In terms of profession, these are mostly students. Most of the data is of students. There are very few profession beyond students. So that way, this particular variable we have put as a cross. It will not be explaining much about the target variable. Similarly, variables like work pressure and job satisfaction, both of these variables are on a scale with most of the values are having a value of 0. Now we are talking about the algorithms, machine learning algorithm which we have used for creating the model. So we looked at random forest and logistic regression. I will quickly talk about them. The reason for picking random forest is that random forest is an ensemble method where it is combining multiple decision trees, so it scores over a single decision tree and hence having higher accuracy. It is also less susceptible to overfitting, and outlier treatment can also be done, which might be impacting an individual decision tree. Also, it is useful for feature importance analysis. If you look at logistic regression in a way is a natural choice for target variables which are categorical in nature, and more so if it is bivariate in nature, and it is also simpler to implement and more suitable for bivariate target variables. We are starting with random forest. So these are the set of variables which we found are found to be of use for classification purpose when we are using a random forest. So the variables which we have looked at are gender, age, academic pressure, CGPA, study satisfaction, sleep duration, dietary habits, suicidal thoughts, work, study hours, financial stress, family history of mental illness. At the same time, there are few variables which were not considered or which were not adding any value for predicting the target variable are profession, job satisfaction, work pressure, city, degree, ID. ID is just a unique identifier. Profession, job satisfaction, work pressure, as I mentioned, these are largely having one common value across the entire data set. So there is not much variation, and hence these variables are not adding any value in explaining the target variable. Now I'm coming to the hyperparameters which we have used in our random forest model. So we have looked at criteria and we have defined for us in our case we have defined the criteria to be Gini index, which indicates a more pure node, meaning that data points in that node are more likely to be belonging to the same class, and which is used for finding the best split. And next is maximum depth. So maximum depth of the tree of an individual tree we have defined this as 5. Maximum features is 5, which is maximum number of features to be considered at each node for splitting. N estimators is number of decision trees to be used in the random forest, which we have which we have defined as 250. Minimum sample leaf, minimum sample size of the leaf which beyond which it cannot be further split is 200. Minimum sample split, minimum sample split in the node which can be further split is 500. So at least the node should have 500 sample for it to be splitted. Random state, which is just used for shuffling the data before it is split, is 42. Now we are looking at the confusion matrix. So if you look at the confusion matrix, it gives the overall accuracy of the model is 82. That means it is correctly predicting the true positive and true negative cases out of all the cases. What is more important for us is to understand the recall, which is basically a measure of all the actual positive cases, how many did the model correctly identify. So this means an 88 score means of all the say depression cases, 88% cases were correctly identified as depression cases. And similarly, if you look at the precision, which is 81%, that again is talking about that of all the cases, 81% were this thing, which basically precision talks about of all the positives, how many did the model correctly identify. So model has correctly identified 81% cases. So precision and recall are the two parameters which are not different in our case, and in a way are strong for supporting the model. Now we look at the ROC curve. If you look at the ROC curve, the area under curve is 90%, which indicates that model performs well in distinguishing depression positive and negative cases. So this is the graph which shows the feature importance, and these have been arranged in their descending order, where suicidal thoughts uh, came out as the most important feature in identifying the depression cases. The top 5 features which we can see is suicidal thoughts, academic pressure, CGPA, age, and financial stress. Besides that, there are parameters like work, study hours, study satisfaction, sleep duration, dietary habits, gender, and family history of mental illness. All these features are contributing overall in explaining the depression cases. Now we are looking at the logistic regression. We are starting with the main output of the logistic regression. If you look at the p-value, overall p-value of the model is at 0.000, which is lesser than the 0.05 score which is required for checking the 95% significance. So in that way, the overall model is significant in explaining the depression cases or the target variable. The log likelihood value too is very different from LL null value, which again is an indicator that model is fitting correctly in terms of explaining the dependent variable. There are 3 variables: gender, work pressure, job satisfaction, where the p-value is higher than 0.05, which shows that these are not significant in terms of explaining the target variable, which is depression. Now looking at the confusion matrix for logistic regression. So here we will see that this too is having a high recall value of 87%, very similar to that of random forest. Even the precision value is at 82%. Overall accuracy is at 84%. So with a recall score of 87% for depression cases, there are lesser cases which are getting incorrectly classified, that is false positive, as not having depression. Because if there are cases which are of depression, and they are incorrectly classified as not having depression, which basically is a major issue. So this, if we look at this particular set of values, 0 is the actual value, which is the actual depression case, and this is a non-depression case, which is 1. So this one are those this one is of depression cases which are 405, but these are incorrectly predicted as not having depression. So we have to minimize these cases, false positive cases, which are actually depression cases, but as per the say algorithm or as per the model, if they are getting classified as not having depression, we have to minimize such incidents or such cases. This is the overall area under the curve. Here again, if you look at the ROC chart, the area under the curve is having a very strong value similar to the random forest, which is at 91%. So which again shows that the model is performing well and is able to distinguish between depression positive and negative cases. This is the cross validation score. We did a five-fold accuracy, and we found that the scores are very similar. The overall accuracy is at 84% for both random forest and linear regression, and at the same time, at each fold, the score is very similar. So that way, the model qualifies, and uh, the cross-validation scores are healthy in terms of supporting the model. This is the overall equation which we can look at, which can help us create a probability using logistic regression output for any new case, and of both of the two ML models which we have used, we feel that random forest makes more sense because it's a model which is an ensemble of various decision trees, and there is a very less likelihood of overfitting. It can capture complex patterns as well as it can handle non-linear relationships as well. So, thank you, friends. I will also quickly take you through our Python module, which basically we can use to predict, which we can use to identify and predict that if there are any depression cases. So if you look at these values, this is basically our Python say code which we have created for a random forest model. And so if you look at these values, if you are going to feed these values for each of the features, it can help us identify whether a new case or any new individual is having depression or not. Thank you, friends. Thank you. This is the end of the presentation. Thanks a lot.